Welcome students. Today we will discuss a very interesting phenomena. We will try to know why the adding of concentrated acid to water is exothermic in nature. We will take example of hydrochloric acid, nitric acid and sulfuric acid. When such acids are added to water and heat is released, why it is happened, we will discuss the reason. Students, this all is due to the intermolecular forces found between the molecular species. We have to consider the intermolecular forces between solute-solute molecules and solvent-solvent molecules and also the solute-solvent molecules. So when you add an acid into water, the water will be solvent. So what kind of intermolecular forces are found between the water-water molecules? So you can see this picture here. The type of intermolecular forces which work between the water-water molecules are hydrogen bonds, which are strong kind of interactions. The another component of the solution is solute. We have to know the intermolecular forces acting between solute-solute molecule also. In case of hydrogen chloride solute, there is dipole-dipole interaction between the HCl molecules. If you want to know more about the type of intermolecular forces found between two molecular species, you should see my video regarding the intermolecular forces which have been made separately and available in my playlist. In between the nitric acid molecules and sulfuric acid molecules also there will be intermolecular hydrogen bonding. Now what happens when solute is dissolved into the solvent? Means your acid is dissolved into water. Let us take example of hydrogen chloride when dissolved in water. As you dissolve hydrogen chloride into water, it will ionize into its component ions, hydrogen ion and chloride ion. Now each ion produced in the solution of acid into water interact with the solvent water molecules. Water molecules have polarity. They have partially negatively charged oxygen atoms and partially positively charged hydrogen atoms. So the cation of the acid will interact with the oxygen atom of water. You can see how water molecules surround the cation. This kind of interaction acted between the water molecule and the cation is called as ion-dipole interaction, which is a stronger kind of interaction. It is stronger than hydrogen bond or any dipole-dipole interaction. Similarly, the anion produced by the acid will also interact with the water molecule. It will attract to the hydrogen atom of water, and here also water molecules surround the anion and ion-dipole interactions will be developed. Means the cation and anion both will interact water molecule through ion-dipole interactions which are stronger than any kind of dipole-dipole interaction or hydrogen bond, and therefore the solute-solvent interactions in the resulting solution will be stronger than solute-solute or solvent-solvent interaction. Means some new force come into the existence and the force of interaction between the ions or the solvent molecule present here will be stronger, and whenever a new force come into the existence, heat is released, and so adding of a strong acid into water will be exothermic. Means it will occur with the release of tremendous amount of heat. As like hydrogen chloride, H2SO4 and HNO3 are also covalent in nature, but when they are dissolved in water, they dissociate into their component ions, and each ion will interact to the water molecules through ion-dipole interactions, a stronger kind of interaction in comparison to the hydrogen bonds found in water or solute-solute molecules, and therefore here also the intermolecular forces become stronger after dissolution of solute into solvent, and so new force come into the existence and the heat will be released, and therefore these acids also on dissolving water produce heat. This kind of solution are called as negative deviation showing solution. Such solution when are formed, they show negative enthalpy change. Means while their formation, heat is released. Thank you very much for listening me.